Okay, so this video is going to be for pages 21 and 22. We're going to look at position versus time graphs again, do kind of a little recap. Okay, so number one, what is the starting position of the caterpillar? So that's just where you are on the y-axis. Okay, so at 0 seconds, you're going to be at 2 meters. At number two, what is the position at 3 seconds? So A is 3 seconds. So we're just going to find out where we are at 3 seconds. So that would be right here. So that is going to be 5 meters. Okay, at 5 seconds, we're going to be right there on the x-axis, so my y is going to be 0 meters. And C, at 7 seconds, I'm going to be at -4 meters. Number 3 is determine the displacement, so we're kind of going to go into change in position now. So from 0 to 4 seconds. So remember, displacement is always your final position minus your initial position. So at 4 seconds, my position is 5. Okay, at 0 seconds, my position is 2, so 5 minus 2 gives me 3 meters. B, from 4 to 5 seconds. Okay, so at 5 seconds, I'm at 0. And at 4 seconds, I'm at 5. So 0 minus 5 is going to give me a -5 meters. And then 1 to 7, so at 7 seconds, I'm at -4. Minus, at 2 seconds, at 1 second, I'm at 2. So -4 minus 2 is going to give me -6 meters. And then D, at 9 seconds, I'm still at -4. And at 0, I'm still at 2. So it's basically going to be the same thing, so -6 meters. Now, average velocity, that's kind of what we covered yesterday. It's just a velocity that connects the 2 points. So from 0 to 4 seconds. Okay, so I'm basically trying to find the slope of the line that connects those 2 points. So my points would be 0, 2. And over here, my points will be 4, 5. So I'm going to take that y2 minus y1. Okay, so 5 minus 2 over x2 minus x1, so 4 minus 0. That's going to give me 3/4, but I can't keep it in fraction form, so I'm just going to turn that into a decimal. So 0.75 meters per second. Then B, 4 to 5 seconds. So let's switch up our colors a little bit. So 4 seconds right here, so I can still use that same point, and 5 seconds is right here. So that point would be, 0, that'd be 5, 0. So those are my 2 points. So basically I'm just finding the slope of that line. So what we're going to do is our y2 minus y1. Okay, so 0 minus 5 over x2 minus x1, so 5 minus 4. Okay, so that's going to give you a -5 meters per second. All right, so from 1 to 6 seconds, let's switch to a different color. So 1 to 7 seconds. So at 1 second, I'm right there. So my point would be 1, 2. And at 7 seconds, I'm right here. So my point would be 7, -4. Okay, so what I'm going to do is I'm going to use my y2 minus y1, so -4 minus 2, over my change in time, so 7 minus 1. This becomes -6 over 6, which is going to give me -1 meters per second. And then lastly, 0 to 9, let's change the color one more time. Okay, and we're just go ahead and do a red. So 0 to 9, so at 0, I get to use that 0 to 2. And at 9 seconds, I'm right there, so my point would be 9, -4. Okay, so I'm going to do y2 minus y1, so -4 minus 2. And then my change in x is 9 minus 0. Okay, so that's going to come out to -0.67 meters per second. Okay, and those are your answers for average velocity. Number 5 is which time interval is the caterpillar not moving? So remember, on a graph, a position versus time graph, we're looking for flat horizontal lines. That's when they're not moving. So I'm going to say from 0 to 1 seconds, that's a flat line. I'm going to say from 3 to 4 seconds, that's a flat line. And then from 7 to 9 seconds, that would be a flat line. So those are the time intervals when it's not moving. Okay, so I'm going to write 0, 0 to 1. 3 to 4, and 7 to 9. Okay, which interval is a caterpillar moving in the positive direction? So let me kind of clear up this graph a little bit, just so we have a little bit of room. So positive direction just means you're going up. Okay, so if I look here, starting at 1 second, it starts increasing all the way until 3 seconds right there. That's the only time where I see it actually going up. So that would be my interval, so 1 to 3. Okay, during which time intervals is a caterpillar moving in the negative direction? So we're looking for any time it's going down. Okay, so it's at 4 seconds, it starts up there and then goes down all the way until 7 seconds. Now you can split them up into pieces if you want, or you can just say 4 to 7 seconds. Now, what is the total distance traveled from 0 to 9 seconds? Okay, so distance is a scalar quantity, meaning it does not care about direction at all. So we're just going to add up the total ground that this caterpillar has covered. So from 0 to 1, didn't move. From 1 to 3, it went from 2 to 5, so that difference is going to be 3 meters. Then it sat still for a second, and then it turned around and went the opposite direction, and it started at 5, ended at -4. So that distance would be 9. Okay, and then it stood still. So my distance, all I have to do is just add those two things up. There is no negative distance. So this is just going to be 9 plus 3. And that gives me a distance of 12 meters. Now, on 9, what is the average speed from 0 to 9 seconds? So the key here is that speed uses distance over time. Okay, so there's a difference between distance and displacement. And I'm going to calculate both just to show you. So distance is what we just counted. We count that 12 meters, just the total ground covered, divided by the time, which was 9 seconds. Okay, so that comes out to be 1.33 meters per second. So that's your answer for speed. Now, if I was looking for velocity, remember velocity equals displacement over time. Okay, displacement is where did you end versus where did you start. So I ended at -4, so right here. Okay, and I started at 2. Okay, so that gap would be a -6. So my displacement is -6. And my time is still 9 seconds. Okay, so I would divide those, and I would get -0.67 meters per second. Okay, so that shows you the difference between velocity and speed. It's still technically the same equation, but speed uses distance and velocity uses displacement. All right, so moving on to the next graph, okay, what is the position of the object at 0 seconds, the starting point? So at starting point, it would be right here. So that is going to be 4 meters. What is the position at 2 seconds? So at 2 seconds, I'm right there. So look on the Y, and you would be 8 meters. What is the displacement from 0 to 4 seconds? Okay, so our final minus our initial. So at 4 seconds, I'm at 8. Minus where we started at was at 4. So 8 minus 4 gives me 4 meters. Number 4, what is the displacement of the object from 3 to 6.5 seconds? So I'm starting at 3 right there, ending at 6.5. So I want to know what is displacement. So my final position would be -4 minus my initial, which would be 8. So -4 minus 8 is going to give you -12 meters. What is the distance traveled from 0 to 5? So we're just looking how much ground was covered. So from 0 to 1, nothing happened. And then from 1 to 2, we went from 4 to 8. So there's 4. Okay, so 2 to 4, we did nothing. And then from 4 to 5, we went from 8 down to 0. So that is 8 right there. So 8 plus 4 gives you 12 meters as your distance. Now, what is your average velocity from 0 to 4 seconds? Okay, so velocity is your displacement over time. Okay, so at 0 seconds, I'm at 2. I'm sorry, at 0 seconds, I'm at 4. So let me clear this up a little bit. Okay, and we'll kind of switch up colors. So at 0 seconds, I have a y of 4. And at 4 seconds, I have a y of 8. So final minus initial, 8 minus 4 is going to give me 4. Over my time, 0 to 4 seconds, is 4. So 4 divided by 4 gives you 1 meters per second. What is the speed from 0 to 5 seconds? So remember, speed uses distance. Okay, so distance is the 12 meters we found in number 5. So 12 divided by my time, which is 5. And that gives me 2.4 meters per second. And number 8, during which in time intervals is the velocity constant? So I'm looking for straight diagonal lines. Okay, so I would say from 1 to 2. And then I would say from 4 to 5. And then 5 to 6. And then 7 to 8. Okay, so those would be constant velocities. Okay, so we're going to go down here. So 1 to 2, 4 to 5, 5 to 6. The reason why I broke those up because as the slope changes, okay, so that's why I broke them up into pieces, and then 7 to 8. During which time is the object not moving? So I'm looking for flat lines. Okay, so from 0 to 1, and then from 2 to 4, and then 6 to 7. So you're just looking for flat horizontal lines. Okay, so 0 to 1, 2 to 4, and 6 to 7. Number 10, during which time intervals is the object moving in a positive direction? So you're just looking for a time that goes up. Okay, so we're going to look at our graph up here. So anytime I'm going up, it looks like I'm going up from 1 to 2, and I'm going up from 7 to 8. Okay, so even though that's below the x-axis, you're still moving up in the upward direction. So 1 to 2 and 7 to 8. Okay, during which time interval is the object moving in the negative direction? Okay, so negative direction. Let me clear this up a little bit. We're looking for anything that's going down. Okay, so basically from 4 all the way to 6, that is the only time I'm seeing where it's going down. So that is going to be 4 to 6 seconds. Okay, what is the velocity during the second second? Okay, or just 1 to 2 seconds. So basically what I'm looking for is I just want to know what is the slope of this line right here from 1 to 2. Okay, so my points would be 1, 4, and my point here would be 2, 8. Okay, so I'm going to do y2 minus y1, so 8 minus 4, over x2 minus x1, so 2 minus 1, and that's going to give me 4 meters per second. What is the velocity from 4 to 5 seconds? So we're going to find the velocity of this line right here. Okay, so my points are 4, 8, and then I'm going to have 5, 0. Okay, so my y2 minus y1, so 0 minus 8, over x2 minus x1, so 5 minus 4. That's going to give me negative 8 meters per second. Displacement from 0 to 8 seconds, so just where we ended versus where we started. So we need to see where we started. So at 0 seconds, I'm at 4. And at 8 seconds, I'm right there at 0. So it's final minus initial. So 0 minus 4 is going to give me negative 4 meters. And then average velocity from 0 to 8. Okay, so basically what we're doing is we're looking for the slope of the line that connects those 2 points. So my points would be 0, 4, and then 8, 0. Okay, so I'll do my y2 minus y1. Okay, so that's going to be 0 minus 4 over my x2 minus x1. Okay, so that's going to be 8 minus 0. And that's going to come out to be negative 0.5 meters per second. And 16, what is the distance traveled from 0 to 8? So we're just going to basically add them all up. Okay, so let me clear this up. Add up all our distance covered. So 0 to 1, we didn't do anything. 1 to 2, we moved from 4 to 8, so that's 4 meters. And then from 4 all the way to 6 seconds, we went from 8 to negative 4, so that is going to be 12. And then we do nothing from 6 to 7, and then from 7 to 8, we go from negative 4 to 0, so that is 4. So we're just going to add all those up. So 4 plus 12 plus 4. Okay, and you're going to get 20 meters. And then speed. So remember, speed uses distance. So that we just found it. So speed is distance over time. So 20 meters over our time, which is 8 seconds. So my speed would be 2.5 meters per second. And that's the end of that page.